Heat and temperature. On a sunny day in summers, we feel hot. Similarly, we feel cold on a winter night. We feel warm on a sunny day in winters. Thus, we can say that it is the flow of heat energy into our body which makes us feel hot or warm, etc. Temperature. When you touch ice, you feel cold. When you dip your finger in hot water, you feel hot. The degree of hotness or coldness of a body is called its temperature. Thermometer. The instrument used to measure the temperature of a body is known as a thermometer. The unit for temperature that we commonly use is the degree Celsius or degree centigrade. There are many types of thermometers available today. Let us look at some of them. Laboratory thermometer. The thermometer available in the laboratory consists of a long, thin, uniform glass tube sealed at one end with a bulb filled with a liquid at the other end. The most commonly used liquid is mercury. This thermometer is able to measure a range of temperature from -10 degrees Celsius to 110 degrees Celsius. Clinical thermometer. A clinical thermometer is designed for measuring the temperature of the human body. It consists of a thin, long, narrow uniform glass tube with a bulb at one end. The thermometer scale is marked from 95 degrees Fahrenheit to 110 degrees Fahrenheit or 35 degrees Celsius to 43 degrees Celsius on the glass case. Reasons for using mercury as thermometric liquid. Mercury is preferred to other liquids because of some specific reasons. Mercury is an opaque, shiny silvery liquid. It can easily be seen through the glass. It does not stick to the glass tube. It is a good conductor of heat. It has a low freezing point, which is -39 degrees Celsius, and a high boiling point, which is 357 degrees Celsius. Thus, it can be used over a wide range of temperature. Scales of temperature. The most commonly used temperature scales are the Celsius and the Fahrenheit scales. 1. The Celsius scale. On this scale, the lower standard point is 0 degrees Celsius and the upper standard point is 100 degrees Celsius. The normal temperature of the human body on the Celsius scale is 37 degrees Celsius. 2. The Fahrenheit scale. On this scale, temperature is measured in degree Fahrenheit. The lower standard point on the Fahrenheit scale is 32 degrees Fahrenheit and the upper standard point is 212 degrees Fahrenheit. The normal temperature of the human body on a Fahrenheit scale is 98.6 degrees Fahrenheit. Conversion from one to another scale. There is a relation between Celsius and Fahrenheit scale. Degrees Celsius divided by 100 is equal to, within brackets, degrees Fahrenheit minus 32 divided by 180. Degrees Celsius divided by 5 is equal to, within brackets, degrees Fahrenheit minus 32 divided by 9. Degrees Celsius is equal to 5 within brackets degrees Fahrenheit minus 32 divided by 9, or 5 within brackets degree Fahrenheit minus 32 is equal to 9 degrees Celsius. Degree Fahrenheit minus 32 is equal to 9 divided by 5 degree Celsius. Degree Fahrenheit is equal to 1.8 degrees Celsius plus 32. Transmission of heat. The flow of heat from a hot body to a cold body or to a colder part of the same body is called transfer of heat. Heat always flows from a body at a high temperature to a body at a lower temperature. The flow of heat stops when the temperature of both the bodies become equal. There are 3 modes of transfer of heat: conduction, convection, and radiation. Conduction. In solids, heat travels only by the process of conduction. The process of transfer of heat energy in solid without the actual movement of particles from their position is called conduction. Good and bad conductors of heat. The materials which allow heat energy to pass through them easily are called good conductors of heat. For example, copper, iron, silver, and aluminium are very good conductors of heat. Those materials which do not allow heat energy to pass through them easily are called bad conductors of heat or heat insulators. Uses of good conductors of heat. Cooking utensils are made up of metals such as copper and aluminium because they heat up very quickly and transfer heat to food. Being a very good conductor of heat, mercury is used as a thermometric liquid. Uses of bad conductors of heat. In cooking utensils and tea kettles, handles are made up of poor conductors of heat. The cold storage is also constructed with double walls, leaving an air gap. This air gap acts as an insulator and does not allow transfer of heat. Convection. Convection is a process of heat transfer in which the particles change their position by constantly moving from the hotter region to the cooler region, thus causing the heat energy to flow. Applications of convection. Ventilation in houses. In house, warmer air rises up and goes out through the ventilators near the ceiling. The fresh, cool air from the doors and the windows rushes in to take the place of warmer air. Sea and land breezes. In the daytime, the land near the sea is very hot as compared to sea water. So, the air above the land becomes warmer and lighter and rises up, and the cold air from the sea blows towards the land to acquire its place. This is called the sea breeze. Water cools down slowly as compared to land. Hence, at night, the air above sea is comparatively hot as compared to that above the land. Therefore, the air from the land flows towards the sea. It is called the land breeze. Radiation. Radiation is a process of heat transfer from a hot body to a colder body without heating the space between the two. It does not require a medium to flow through. It does not heat the medium through which it passes. Applications of radiations. Firemen wear highly polished and shiny suits. The heat of the fire is reflected by their clothes. Black surfaces absorb most of the heat falling on them, while white surfaces reflect most of the heat falling on them. So the base of cooking vessels are painted black so that they absorb more heat. Room heaters are provided with shiny plates so that they reflect almost all heat. Vacuum flask. Vacuum or thermos flask keep hot liquids hot and cold liquids cold. It is done by stopping or reducing transfer of heat by conduction, convection, and radiation. Transfer of heat by conduction and convection requires material medium. The vacuum present between the walls of the glass vessel prevents transfer of heat by conduction and convection. The silvered walls reflect back, thereby preventing transfer of heat by radiation.